Hi class, welcome to Grad Stats Lab Series, Lab 3 on correlation and simple regression running in JASP. So our goals here are building some skills to prepare for conducting regressions. And it requires an understanding of the basics of general linear modeling, specifically that regression is based on correlation. And those assumptions and limitations of correlations carry over as we start evaluating our first simple or one predictor, one outcome bivariate regression. The materials you'll need, you need the data set called lab3_survey.save and also the starter tables in Excel. So go ahead and grab those and we will get started in JASP. Okay, starting in JASP, the first thing we want to do is open the data set. So you'll need to go to wherever you've saved the data set. lab3_survey.sav. And we open up on just some of our totals and the ID variable. So this is pared down and we don't have any categorical variables to work with. We're only looking at the continuous variables here. And the type of question that regression would tend to answer would be something like, does one's perceptions of control predict their experience of perceived stress? So does that variable of perceptions of control of internal states, does it have a predictive ability on one's perceptions of stress? We hypothesize that perceptions of internal control will be a negative significant predictor of total perceived stress. So here's our study variables in the whole data set, but the ones we'll focus on more often are going to be the perceptions of control and perceptions of stress, the ones that will be in that regression model. But we do need to gather descriptives for the write-up. So we'll start there with descriptives of our continuous variables here. In descriptives, we'll grab that input area and make this bigger so we can see it. And let's go ahead and let's get all of these. And I'm going to put them in a specific order. So I'm going to put perceived control and then stress and then positive affect, negative affect, and total life sat. And this is because the variables of interest, the ones that are going to be in the regression, are perceived control and perceived stress. And that way when we set up our correlation table, it'll be in that order. So it's something to think about, as you are looking to the write-up. But here we have our mean and our standard deviation for each of those continuous variables, which is what we would need in the write-up as well. And then, so we'll edit this to say descriptive statistics all study variables. And that way we know we have them all there. In statistics, this is where we can also add in skewness and kurtosis so that if we want to evaluate the normality, we have that information right there. And we also can add in the Shapiro-Wilks test so that we have that information. So it collects all this information we've been gathering, the mean and standard deviation, skewness and kurtosis, and Shapiro-Wilks test. So it's good to have all together. Another thing that we're going to want to have is the relationships between variables. And we look at that with correlations. So we're going to fold this away and grab a correlation input panel. It's going to be under the regression icon, and you want classical correlation. So in here, again, we want all of these to make our correlation table with, but again, we're going to put them in the order of the two that are mostly what we're looking at up as at the beginning, and the others at the bottom. Okay, total perception of control of internal states, total perception of stress, total positive affect, total negative affect, and total life sat. And this way we have them all together and we're able to see the correlation table for them. And let's take a look at this. Here we have the two that are going into the regression. Perceptions of control and perceptions of stress are coming in at a negative 0.581 correlation. And that's important to know because one of the things we look at in terms of are these variables suitable for a regression is we consider, are they related linearly, bivariate linearity. So that's something we will come back to as well. But here we have the startings of our correlation table. And let's get an idea as to what our endpoint is going to look like here. Our correlation table looks like this according to APA. So this is in our APA manual. It's sample table 7.10, and it's about page 215 in your book. And we have a column for mean, column for standard deviation, and then just the lower triangle of the correlations between the study variables. So this is kind of where we're aiming as we're gathering information from JASP to build this table. Typically I put the count just in the caption because usually my tables are getting way too wide and I need to kind of narrow them down a little bit. So we have the correlation. We know their significance value. All of them seem to be significant at less than p less than 0.001. So they would all have those significant correlation indicators. Over here in our input panel, we can play around with it. Like we can flag significant correlations where it puts the asterisks on there. We can add the sample size if we wanted to know how many were in each one, but sometimes that's too much information for what we want in the table. So I'm going to turn off this so it's just the p-values. Let me see. Since I know they're all significant at p less than 0.001, I'm going to turn off report significance so that I have just the numbers here, and see if I can copy this in a way that would let me put it into the Excel table. Doesn't look like it's going to let me just copy, so that's okay. What do we want our correlation table to, how do we build that? We know what we want it to look like as far as in terms of APA, but then I gave you guys this starter tables Excel to help you get started on tables. Now this first tab is just for means and standard deviations, so this does not have enough information for us when we're building a correlation table. But if you go to the next tab called Table Core, here's a fuller table that we can use. Now we have to update it. These are different variables that we're not using, so I can delete that information, and I need to update the note because we're not going to be talking about GPA. And we saw that all of our correlations are p less than 0.001. So I can go ahead and put that in here. And it can just wait until I have more information in here. In fact, I'm going to pull this over and go to my JASP window and see if I can just look at this. I think this will work. I'll be able to see those numbers and see my Excel sheet. Yep, that'll work. So now it's easy for me to just type them in. I know I need to do the variable names, and I don't want the variable names. I want more of the label here. So this is perceived control. Got to misspell. And then, and you'll notice that I'm fighting the capitalization a little bit. I'm used to capitalizing each word. But when we look at how APA wants it on the variables, it looks like only the first letter is capitalized about the variables when they're in this table. So that's why I was making sure I kept it consistent with that. And here is the information we want. We want the mean and standard deviation and the correlations across these. So let me get back to my JASP window so I can see these numbers. So the correlation between perception of control and perception of stress is negative 0.581. And that's a pretty strong correlation. Your correlation cutoffs are 0.1 is weak, 0.3 is moderate, 0.5 is strong, and 0.8 is like very strong. So this is a negative correlation, that's the direction, and it's pretty strong at a 0.581. That's strength and direction there. And we know all of these are significant at p less than 0.001. So now I'm just going to type the information in. Now in Excel, whenever we put like a negative or an asterisk, something like that, it's going to think that we want to compute something. And here we don't. We're just wanting the negatives and the asterisks because they tell us something about the correlation. So the way to get around that with Excel is lead with an apostrophe or a single quote. And then you can go ahead and type in your number, negative 0.58. I'm only going to go to 2 decimal places. And I can put 3 asterisks because it's significant at that level. So I don't need the leading 0 because correlations don't go above 1 anyway. Correlation has a range of -1 to +1. It's never going to be more than 1. So I don't need that leading 0 for correlations. So my next one is 0.46. Okay, so I have all of my correlation coefficients in here, and I still need to put in the mean and standard deviation for each of these. So I can get that from the first table we pulled. Okay, and all of these are centered because that is how APA pretty much looks for them to be. And I can select the whole table and make sure it's aligned to the top, which makes it easier when I go to cross this into Word that I don't have some cells that are aligned in the bottom and some that are aligned to the top. So I'm going to let that just sit there for now, and we will go forward in looking at our assumptions for regression. So we are going to check out univariate normality and bivariate linearity. And we're mostly looking at total perceived stress and total perceptions of control. So I'm going to start a new input area just to keep that separate, since that's where I want to go with my regression. So let me get a descriptives for TP stress and TP COISS. So I'm just going to take these two and put them over here to take a good look at them. And here I have the mean and standard deviation. Like before, I can review their skewness and kurtosis in terms of, are they very peaky or flat, and are they negative or positive skewed? So my kurtosis scores and my skewness scores. And then the other thing we look at is Shapiro-Wilk. So according to Shapiro-Wilk's, both of these variables, perceived stress and perceived control, are less than p05. So according to Shapiro-Wilk's, both of these variables violate normality. But we also want to look at the histogram. So we want to come down to basic plots, distribution plots, so that it will build a couple of histograms for us. There we go. So we have the distribution of total perception of stress and the distribution of total perception of control. And we can see a little bit of outliers here on the negative side, so some negative skew going on, some positive skew on total perception of stress, but they both don't look too bad. You would report what you see. Like if you feel like this is normal, pretty normal enough, you would let your reader know, hey, this looks pretty normal to me, even though it's got a significant Shapiro-Wilk's test, which would indicate a violation of normality. So in all of them, you're the one doing the assessment, the visual assessment, and you just say what you think. You still let the reader know if the normality test ended up being significant or not. So the other assumption we need to check out before we look at a regression between these two is bivariate linearity. In other words, is there a linear relationship between these two variables? So we're going to get us another correlation panel, and we're just going to do the correlation between TP stress and TP COIS. So those are the only two we want over there. And in this, again, we have our correlation, but we want to see the scatter plot here. So we're going to go to plots and scatter and take a look at what's going on here. So we have total perception of control and total perception of stress. And if you end up with having control on your y-axis, all you have to do is change the order of these. So I have total perceptions of stress first and perceptions of control second. And that aligned it well to where my stress or my outcome is on the y-axis and my total perceptions of control are on the x-axis. Now it does kind of cram it all in together. That we can't fix that here, but we do have other ways to pull the scatter plot. And they already drew in the best line of fit, which is helpful because then we can see if there's a downward trend to the data, which looks like it and makes sense with the correlation being negative 0.58. Now, we do have another way to ask for a scatter plot in JASP. We would go back up to our descriptives between TP stress and TP coas. And in this area where we were looking at the histograms, we can also come further down in our input panel to the area near the bottom. It's called customizable plots. So in here, we can add a scatter plot, and I put in that it would be none on graphs above or to the right of the plot, and I left add regression line that's linear, and I can turn off that 95 confidence interval on that line. So here I have a scatter plot that's got my line of best fit through the data points, but notice how now my TP stress is on the x-axis when I really would want it on the y-axis. No problem. Let me see if changing the order up here will help that. There we go. So this is TP stress on the y-axis and TP coas on the x-axis. So that might be one that I'd like to save the image so that I can use it in my write-up. Cool. Going back to our correlation information here. So this would indicate that we have a rationale, we have justification for doing a regression because these two seem to be linearly related. So that's those two assumptions we wanted to check out, which was univariate normality by looking at the distribution and the Shapiro-Wilks test, and bivariate linearity by looking at the scatter plot and the correlation test. We'll go ahead and look and see what they have here. No, and options. No, those are fine. Excludes cases pairwise just means that if a case is missing one of these values, it's not going to have it in the analysis, the correlation analysis at all, because correlation needs both. It needs the perception of control value and the perception of stress value for a case to be included. And up in here, in our correlation, we can do sample size and be able to see that there were only 426 cases out of all the cases that had both total perception of control and total perception of stress on the same case. So it's a little bit lower than our full sample size. Alrighty, so we've checked out those assumptions. Next thing we want to do is a regression. For this, we're going to get another panel from regression, and we're going to linear regression. And again, our interest is total perception of control a predictor of the dependent variable of total perception of stress? So we want stress as the dependent variable, and we want perceptions of control as the factor. Or we can put it under covariate. What JASP is doing here is it's thinking that factors are only categorical variables, whereas covariates are continuous. So we'll put it under covariates. And now it starts filling in our information here. We have our ANOVA test. That's the test of the model itself, because now this isn't just a correlation between variables. This is a model explaining the variation in stress. So according to the ANOVA model, we have a significant model here. The F-test is what's used for regression and ANOVAs. And the way we report this is with our F, the degrees of freedom being 1 in 424, the estimate of the F-test, and the significance of the F-test. After that, we're looking for the effect size. What is the effect size of this regression? And our effect size is going to be R squared. So right there on the H1 line, our R squared is 0.337. So we're still missing another piece of information that we need to report the model, and that is the confidence interval of R squared. So we'll look and see if JASP will give it to us. I looked in model, I don't see it here. I'm looking in statistics. It has confidence interval. Let's see what this tells us. Okay, it gave us confidence intervals we need for the coefficients, but not for R squared. Let's see if we have, nope. Nope, we don't have the confidence interval for R squared as part of JASP. So what we'll do is we use a alternative website for calculating it, and it's called Daniel Soper. So I'm going to go Daniel Soper, and it brings you to this web page. And what we want to do is scroll down. It's in alphabetical order, so we want to go down to regression right there and fold that down, and in the regression area we want the R squared confidence interval calculator. Grabbing that, we need 3 pieces of information: how many predictors, what is the R squared, and what is the sample size. So we have one predictor. We're saying that our predictor is perception of control, and our observed R square was 337. So that's what's going to go into here. And then our sample size, remember only 426 of the sample had values for both total perception of stress and total perception of control. So 426 is our sample size for this regression. We hit calculate, and this gives us the 95% confidence interval for the R squared. And we can just copy that information. It's not in the right format with the R squared in the middle like that, but I can at least get the numbers so that I can put them into my write-up. Now those are the pieces of info I'm going to need for the model, but I still need some information about the coefficient. When we look at our coefficient table down here, we see that perceptions of control has an unstandardized regression coefficient of -283. That means for every 1 unit change in the predictor, perceptions of control, we're expecting a decrease, that's the negative, in the outcome, total perceived stress. So every 1 step up in perceptions of control, I have a 0.283 decrease in stress level on a, estimated from the data that are already in the data set. Along this row about the coefficient, we also have the standardized regression coefficient of -581. And standardized regression coefficient is an effect size. So we would want to have that for our write-up as well. We see that the p-value is significant at p less than 0.001. indicating this perception of control is a significant predictor of total perceived stress. And then we have the confidence interval for the unstandardized regression coefficient. So even though it was estimated at negative 0.283, it could have been anywhere between negative 321 and negative 246. And when you're looking at confidence intervals, what you're paying attention mostly to is between the upper and lower bounds is 0 there. And we have two negative numbers, which are both to the left of a number line 0. Whenever you do have a 0 between those two numbers, it means it's not a significant item. It's not a significant test or a significant predictor. But all of that information you're going to be using in the write-up itself. So you start typically with a level 1 heading of results and level 2 headings letting the reader know if you have different sections in your results. We start by letting the reader know some general information about the data set, like how many there were, and I went ahead and used the 426 because I know we're going towards that regression. You could put the total, like the 439 that the total data set is here, and then later on when you're talking about the regression, you would have to let the reader know that out of the data set, only 426 were used in that regression. I just put it up front since that's all we're talking about in this results. In general, the relationships between study variables were significant, and you let the reader know where they can find that table. And that's one thing we wanted to do, is look at getting the table from Excel into your write-up. So we'll go scroll down there. We'll get to this new page and see about putting the Excel table into here. So we already put our information in here. And we saw in the data that, let's see, when we're looking at the correlation between all of the variables, and if we look at sample size for that one, we see that it goes anywhere from 426 to 436 is the highest number here. So I'm going to put that in the caption area of the table. So right there after the word note, put n equals 426 to 436. And I'm going to put a period at the end of that. And I want to italicize the n. Okay, that looks good. So all of my information is in here, and I'm going to select this whole table. I'll get the top left corner, and I'll come down to the bottom right corner, and I'm holding the Shift key so that I can select the whole table. And then I'm going to right-click and copy and move over to my write-up page. And I'm right-click and paste, or Command-Control-V will also do it. And see what we have here. Looks like it's exceeding the margin here on the right side, but otherwise it's looking okay. I'm going to select the whole table with that little crosshair item in the top left. And when I select the table, I have more options in the menu. In the menu, I go to Layout, and I want this Auto Fit to Window. And it looks like it's shrunk in pretty fine without like doing extra rows for things that I would have to adjust. So this one did not fight me too bad. I want to change this to Table 1. And that looks pretty much ready. So cool, not too bad at all. So then I'm going to go back up to the write-up and look at what else we have. So table 1, your tables come before your figures after the write-up. And I'm letting the reader know that they can see table 1 for descriptives and correlations between all the study variables. Then we're looking at how we evaluated the assumptions. So prior to the analysis of the regression, we needed to evaluate the assumptions of univariate normality and bivariate linearity. You let the reader know how you evaluated the assumptions. And again, you first inspect the plots. Histograms are used when you're looking at normality, and scatter plots are going to be used for bivariate linearity. And you let the reader know what you thought of those histograms. Did they seem normally distributed or not? And you also let the reader know the results of the Shapiro-Wilks test. I put that I thought that the total perceived stress seemed pretty normal, but the total perception of control seemed to have a negative skew and several outliers. And both of them had a significant Shapiro-Wilks test. The assumption of bivariate linearity was evaluated visually with a scatter plot, and you let your reader know which figure is the scatter plot. And the general trend of the data indicated a negative linear relationship. When we looked at it and we saw that downward trend, you let the reader know what you saw. And it was confirmed with a correlation test. And for your correlation test, in general, you're letting the reader know what kind of test was run, what the estimate was, the significance, and the effect size. We put more information in our linear model test, but this is all we need for a correlation test. Now that the assumptions are reported checked, we let the reader know about the model, what turned out in trying to answer that question about if total perceived stress could be predicted by one's perceptions of internal control. And results indicated a significant model, and then you want to give your reader this stats line. And all of this information, except for that confidence interval that we had to go to Daniel Soper for, all of this information is in our output. So we're letting the reader know that it was an F test. The degrees of freedom were 1 and 424. So going back to the regression, degrees of freedom were 1 and 424. The estimate that we got for the F test was 215,583. You can do 5.8 or 6, like that, no problem. What was the significance level of the model? The model, that ANOVA table, had a significance level of p less than 0.001. And then what was the R square? It's up here in the table ahead, 337. And then what was the 95% confidence interval of R squared? It was 2641, and that's the one we had to go to Daniel Soper website for. A interpretive statement you have here is that the regression model explained about 33.7% of the variation in the outcome, total perceived stress. And the way we get that 33.7 is you take R squared and you turn it into a percent. It tells you how much of the variation in the outcome the model explained. So that's all about the model so far. And then we go into the details on perception of control as a predictor. Perception of control was found as a significant predictor, and then we have this stats line for perception of control. We have the unstandardized regression coefficient, we have its significance level, and we have the beta, the standardized regression coefficient, which serves as an effect size of this estimate. And then our 95% confidence interval pertains to the unstandardized regression coefficient. And those numbers were also in our output there. If you're not seeing your confidence interval information, it's because you need to come over to the input panel and you need to make sure under statistics that you have confidence intervals checked off there. So we can say that our hypothesis was supported because the model was significant and the coefficient for perceived control was the significant predictor. Each 1 point increase in perceived control predicts or expects a 0.28 decrease in the total perception of stress. And our prediction equation that we can write from this is that when we predict perceived stress, it is the intercept or the constant, and that is right here where it says intercept. You want the one that also has TP-COAS on it. So here's your intercept for the linear model on this H1 line, 43.92. And here's your regression weight for total perception of control, negative 0.283. So those are the numbers you need to be able to write this equation. We have the intercept and the regression weight, which was negative 0.28, and it pertains to the change we're expecting for each 1 unit increase of perception of control. Okay, and then after that is where you would find your appendix, your table. Your table comes before your figures, and each item, the tables and each figure, gets its own page. So you would have a figure 1, and then the next page for figure 2, and then the next page for figure 3. So that's what your write-up would look like. Okay. Again, the way you save your output is you export the results. You can do it over there in the results pane, or you can also do it over on the side in the menu bar, export results to your computer, and you put it in your folder that you know where it's at. So Lab 3 JASP results. And what you're going to keep for the homework is that results HTML. Okie dokie. So we covered a lot there. It was a lot of information. You can look over the lab sheet for SPSS if you want to see like highlights of where I'm getting the information from each table. And also you have examples of write-ups there as well. And we were able to describe our study variables in terms of mean and standard deviation, and looking at their univariate normality in terms of evaluating the histogram and Shapiro-Wilks, especially for those two variables that we were going to put into the regression, because we needed to check the assumptions of univariate normality and of bivariate linearity, which is our scatter plot and our correlation test. Finally, we were able to run that linear regression and be able to pull the information out of it that we needed for the write-up. We also worked with getting data from the output to Excel to Word, and there's different ways of doing that. I know some of our programs say that they will create an APA table for us. Don't trust them. Go ahead and look at it, make sure it's right, because usually they get something wrong. And that's it for Lab 3, and I will see you in the next lab.